Good day everyone and welcome to the third module on our high voltage and safety course. In this module we will be focusing on the high voltage labeling and recommended practices. So think of the high voltage labeling like the clear road signs that we usually see on the highway. These signs will guide us to make safe decisions, it will warn us about potential dangers, and in general ensures that everybody follows a set of rules and a set of recommendations. Let's have a quick overview of what we will be covering in these models. So we will have basically two main topics. First, we will discuss the importance of the high voltage labeling. We will see how the labeling grew out of a need to reduce the electrical accidents and to meet the regulatory requirements. And then we will review the recommended practices for the high voltage labeling. We will take a closer look of the standardized symbols, the colors, the durability considerations that designs needs to have, the placement of the labeling and procedures that are required when we are, for instance, de-energizing the systems. So let's start by the importance of the high voltage labeling. I don't know, but if you know, but back in the 1970s, the electrocution was one of the leading causes of workspace fatalities in several industries. Around 600 electrocutions were occurring each year, and because of that, there was a global concern and there was the need to have robust safety measures. Over time, the standards arrived, and particularly there is this NFPA 70E standard that was introduced and helped to reduce the fatalities dramatically. And what this standard was doing was basically emphasizing the correct labeling and the use of personal protective equipment, as well as proposing strict safety procedures. As you can see over here, the evolution of this standard over and the evaluation of these standards over the years have shown statistically how it has been a significant decrease in the workspace electrocutions, with numbers indicating fewer than 100 fatalities annually, considering that we were starting even in 600 or even higher numbers than that one. High voltage labeling many times sounds like a small detail, but actually it is the heart for preventing electrical incidents. When a label grabs our attention, like for instance a sign saying danger on a fence area, it forces us to think, like to say like, wait, what is happening behind here? Is it safe for me to be here? And that momentary pulse can literally save many lives. As we go forward, keep in mind that labeling isn't just about compliance with rules, but it is actually about building a strong safety culture where at the end everybody will understand the risk of the working with electricity, and everybody will have the same will take the same measurements of protection regarding the space where we are. So, what is the purpose of the labeling? So, high voltage systems may be deceptive because you don't always see the danger in the same way as the danger that we can see maybe when we have a spinning blade or when we have open flame. In all of these cases, it's very visible that it is a danger around us. In the case of electricity, it is not that visible. The cable may look inoffensive, but the real is that there is a big hazard behind it. So that is why visibility and clarity of the labeling is crucial for electrical shock and for prevent electrocution in general. The labels will have three main purposes that are stated here. The first one is going to be the safety warning. Those labels will alert everyone. It will alert the technicians, the operators, the first responders, all of this, and it will alert about potential electric shocks and the severity of the risk. Advanced warnings will help people to take the necessary precautions, like for instance wearing the protective equipment or shutting off power, or to not get closer to the area. Also, another purpose is to have regulatory compliance. Different regions have different rules. Some of the rules, we will explore them later on in this course, but it will depend at the end of the regional bodies. And the labels ensure that you are meeting the local obligations, and this will help us to avoid penalties and, more important, to prevent incidents after all. And the last one is the identification. If a component is marked as high voltage, people intrinsically will handle it with extra care, and it will use special tools. Also, in an emergency, for instance, these labels will guide the first responders to cut the power and to avoid certain areas in a location. So all of these three elements and three reasons create a safer working environment and reduce the likelihood of serious electrical accidents to happen. To make the labels effective, in general, we need to consider four key elements. That is, first, the color of the label, the symbol, the text, and its durability. In the next slides, we will detail each of these ones, but in general, the color for high voltage labels, the color usually is orange, and this is typically used, although red and yellow may be added to include some emphasis. Orange stands against many backgrounds, so it's very visible, and it makes makes this color a great choice for catching attention of the people. For high voltage, when we talk about the symbol, we often can see like a black lightning bolt inside of a triangular shape, and this is the universal sign of electric hazard. And basically here, regardless the viewer language, we can all have a common understanding that this is electric hazard. On top of it, we usually include text, so clear warnings such as danger, high voltage, or risk of electric shock, or keep away. At the end, we leave not ambiguity on what is meant to be done. In some regions that we have several languages, we may require to have the signs in several languages, but in general, this is the text must be understood independently of the region. And the last of our elements here is the durability. If a label fades or falls off, it does not longer serve its purpose. That's why we choose materials that are resistant to heat, to chemical, to wear, and the label has to endure the same environment that the vehicle and the equipment will face. From extreme weather to engine heat or corrosion, all of these elements needs to be considered when we are designing the label to be sure that it is good quality and it will not fade off. At the end, these four key elements will create a label that are both instantly recognizable and also that it will be long-lasting. And that's basic for any safety system. Let's go one by one and let's see what are the specific requirements of the color, symbol, text, and durability. And let's check for doing that. Let's start with the standardized symbols and colors, and let's dive into the recommended practices and the methods that the organization worldwide have tested and have proven to be effective. So around the world, there are several organizations that play a huge role in developing and also in harmonizing the safety standards for high voltage labeling. And here are some of the key players around the world. We have, for instance, the ISO or the SAE. ISO is the International Organization for Standardization, and we also have, for instance, the IEC, that is the International Electrotechnical Commission, and all of these organizations set the baseline and the guidelines that many countries adopt and also adapt to their specific to the specific situation. In the United States, for instance, we also have the OSHA and the ANSI that will define the rules and the best practice that the business, specifically in the US, must follow. And they all often aligns with the international norms that are these ones over here. In the European case, we also have the CE marking and the EN standards that at the end governs how the equipment should be labeled and should be tested, ensuring the product safety across the European Union countries. This global effort will ensure that someone that is familiar with labeling in one region can safely work on equipment even if it is not in the region. So by unifying visual colors and terminology and standards, helps to eliminate confusion, and after all, brings a safetier and standardized work environment. Here there is one of the key international standards, that is the ISO 7010, and this standard organizes the safety signs into different categories and also give recommendations for those safety signs. In this case, the ISO recommends these 4 main categories for the signs. The first one is the prohibition signs, and as its name says, basically it will stand, or it will call the action for prohibiting something. Like, for instance, you cannot smoke here, or open flames in certain areas are forbidden. Then we have the mandatory signs, and this basically indicates required actions. For instance, wearing protective gloves or wearing protective equipment, and it at the end indicates that a particular course of action must be taken. Next, we have the warning signs, and this is alerting the users to potential dangers, including the high voltage dangers. And why is this categorization so important? So at the end, this categorization helps everyone to quickly grasp the context of the sign. For instance, if we imagine that we are in a very busy shop floor with hundreds of signs, each category is shaped and a color pattern cut, it will at the end reduce the noise and will tell you instantly if you are facing a hazard, if you are having a prohibition, or if you are having a mandatory action. So to have these categories creates a rapid recognition of the system, and your eyes and brain can filter the signs more effectively, improving the safety on site somehow. The last one of these categories is the fire equipment and fire action signs, that basically, as the name says, is for directing people to the fire extinguisher and the closer exits. And with this, we conclude like the general division of the type of signs that we will have. The color and the shape are also very important when we are designing and when we are using our labels. They do way much more than just to look nice, since this color and shape will trigger automatic our responses. According to the ISO 7010, a safety sign color and shape are gonna be the first elements that will catch your attention and that will at the end trigger one reaction in you. So for instance, red usually means prohibition or fire equipment, and as it is a provision, we can relate it, for instance, with the stop signs or the fire extinguishers that we know. Then we have the yellow signs that are signaling caution, a universal slow down, there is a danger, be caution, and we can accompany it with the triangle, for instance, that makes a very international and universal sign for caution, danger. We also have the blue that indicates mandatory actions, as we mentioned, like wearing ear protections in loud environments, or wearing protective equipment, wearing gloves, and so on. And the green is generally aligned to the emergency exits and the first aid equipment. Here we have 4 different examples of the colors and shapes and how they will catch our attention, and it will mean something different in this, based on this standard. While the symbols and the colors are the first thing that will draw your attention, we also have another resource that is the text, and the text is gonna be the one that gives us the critical context. According to the text, the ISO 7010 have some recommendations. The first one is that the text has to be very clear and concise. So the wording that we are using have to be very short phrases, like, for instance, danger, electric hazard, keep out. So it's very concise, and that will avoid confusions. Also, another recommendation is that it has to be a consequence statement. So for example, to put specifically what is the consequence, it will compel the people to take the warning seriously. So if we write down specifically risk of electric shock or cause severe injury or death, it will immediately create awareness, and it will make us take the label way more serious. There are different terms that we can use. On the one side, we have, for instance, the word danger, that is used when we have an immediate hazard that could be fatal, and usually this is written in black letters with a red background. We can also use the word warning, and the warning is a serious hazard that could be fatal. We usually use then black letters as well in an orange background. Then there is the word cautions, and caution is what we use when there might be an injury or equipment damage, and in that case we use the color yellow as the background and the black letters. And finally, there is the notice. This is important information that is not necessarily tied to a personal injury, but it is a reminder, like, for instance, putting the correct personal equipment or not wearing certain type of jewelry or so on. And in this case, we use a blue background with white letters. To conclude here, putting the correct word on the label will help the people to gauge exactly how dangerous the situation might be. If it says danger, you should immediately think, this is really serious. I need to follow every safety step possible. Whether if there is caution, maybe I can be a little bit more flexible. I can analyze the situation, but it is not a life and death situation. When we have the color, the shape, and the text, and they are all used together, regardless of the language of and the background of the people, in general, everyone will be able to understand that the hazard exists, and also how severe it might be. So this layered approach that is proposed by the ISO 7010 ensures that there are not misses in the message, and that we are keeping the brokers and the general public safe around any high voltage system. And it was mentioned before, the label is not only as good as it is designed for, but it is also very important to take into account the durability of the label. If the label fades or peel off within a year, it practically is worthless after it is gone. So when we are designing the labels, we have to take into account the materials. Labels should be weather resistant, they have to be heat resistant, they have to be chemical resistant, abrasion resistant, they have to be at the end suitable for the environment in which they will be used. We have to use a strong adhesive that will maintain it firmly, and it will be keep basically secured and protected from the exposed moisture, for vibration, for temperature shifts, and so on. The quality on the printing, it has to be very good. And also we need to have the environment resistance. I mean, so the label will not degrade with the UV rays, with the cold, with the intense heat, and so on. In addition to this, we usually have to do regular inspection. That is also key. If the label isn't legible anymore, it must be replaced immediately, and that might sounds like extra work, but at the end it is important to have them in that way that we prevent the accidents. Let's take a look here now of some of the examples that you might see and that are related then with the context of high voltage and battery systems. So in the category of warnings, we have, for instance, all of these electric shock warnings that are characterized by the lighting. We also have, in the category of prohibition, we have these different signs that, for instance, say no open flame or do not extinguish with water, and that make it very clear what is prohibited. For instance, to not wear metallic footwear and to not wear any metallic elements with you. From the mandatory signs, we have, for instance, these signs that are very clear visually, even if they don't have words, none of those, that it is recommended to wear safety footwear, a recommendation of disconnect the main plug in front in the electrical outlets, to wear protective gloves, and so on. And also in the category of the fire and first aids, we have these 3 signs that are, for instance, showing where there is a doctor, what are the emergency exits, and also, for instance, the location of the heart, the defibrillator. Each icon quickly conveys on what you should or what you shouldn't do. In some cases, these icons might be paired with the text, but often the symbol alone is enough, and I guess that's what makes the label so magical and so universal for all of us. And besides of this, another factor that often it is overlooked is how big the sign should be. In general, the signs have to be designed in such a way that you can see them from the distance. For instance, you can, or we imagine that if you are walking through a very large facility that have a lot of high shelves and that have machinery everywhere, if the warning sign is very small, you could be walking next to it, but it wouldn't be noticed at all. So there is another regulation over here, this ANSI regulation, that states specifically how each inch of the text height should be readable about 7 meters away. And this is a general rule that helps us to size accordingly the letters and the sign, so it can be visible from a good distance. In addition to that, in areas where the natural light is not enough, in those cases we need to add additional lighting. We can use, for instance, photoluminescent or glow-in-the-dark signs, and this is especially needed, for instance, in the emergency exits that needs to be visible even when there is a cut of energy. And ultimately, the safety signs have to be also visible, understandable from whenever the people might be walking or working, and that might invest into bigger signs, high contrast of colors, good lighting, and ensure that everyone stays aware of the potential hazards. Specifically in the automotive application and in the electric vehicles, there are two very important standards. One is the SAE. The SAE is the Society of Automotive Engineers, and those standards are these two over here. Basically, the SAE J3108, it specifies the labeling of electric vehicle systems and how that labeling will help the first and second responders, as well as others who might interact with the vehicles. And the other standard is the J2936, and this focuses particularly on the battery labeling and ensuring the correct warnings and the details that are displayed in the battery systems. Why does these two standards matter? Or in general, the labeling in the automotive and the electric vehicles matter. In case of an accident or in a maintenance scenario, for instance, the first and second responders should be able to catch the labels. In this case, as high voltage is related to the color orange, they should be able to understand quickly, this is a high voltage, I need to be extra cautious. This label don't just reduce the risk of training professionals, but they also guide, for instance, firefighters or general operators or anyone who might be handling the vehicle, because it's very clear and there is a clear warning about it. By following these guidelines, we ensure consistent and easy to identify labeling across the different models and types of vehicles, between electric vehicles or full electric vehicles, hybrid electric vehicles, mild electric vehicles. All of them should follow these standards, and ultimately this improves the safety of everyone on the roads. So now let's go and understand how the standards will guide in creating those labels, and let's take a closer look on why do we use the orange color and why is so important this color. So why we don't use neon green, fluorescent pink, or any other color to identify the high voltage? The reason is because the visibility of the orange. Orange is very highly visible in almost any lighting conditions. Either we are in a bright sunlight or in an industrial setting with low lighting conditions. In all of these cases, our eyes naturally pick up the orange because it contrasts very well with the different backgrounds. And that's the reason why, for instance, the hunters wear orange bells, or the road workers also have the orange cones, because it's a color that can be is very visible. In the high voltage environments, this visibility is very, very important. So when you spot orange wiring or orange label or an orange connector, it should immediately signs that there is a potential electric hazard and that there is a high voltage in that connection. It is almost like the universal caution light. You see something orange in an electric vehicle or in an industrial machine, and you should be thinking this could be carrying high voltage. I need to double check the power status. I need to see if this is an active line. I need to wear my protective material, my protective personal equipment, and I have to follow all the necessary procedures. It's simple, it is quick, it is efficient, and it will potentially save many lives. As we have mentioned, there are several bodies that enforce the use of labeling, and also for having this universal understanding on those labels regarding the color orange. All of these organizations that you are seeing over here agrees and specifies that the color for high voltage and electrical hazard is going to be the orange. So they all agree on the same standards. We have, for instance, the OSHA, that is the Occupational Safety and Health Administration. In this, they specify that the orange is used to mark hazard parts of equipment and areas, as well as high electric voltage. The ANSI classifies the orange as the color for warning signaling, as well as high voltage. The International Electrotechnical Commission recommends the orange for warning labels in high voltage components, and the ISO also uses orange for warning signs, and frequently in high voltage environments. And another important topic of the color orange is that it's not only used in the wires and in the cables, but you will see it in many other parts of the battery. We can see, or of our electric systems. We can see them, for instance, besides of the wires and the cables, we can see the orange color also in the connectors. High voltage connectors, like those that are used in the charging systems, are usually frequently orange for having the quick identification. We also have these plastic components. Some high voltage battery have covers and motor housing features, and all of these have the orange color to help to identify the hazard, as well as the labels that are presenting the hazard warnings or access instructions of high voltage parts, and so on. Up to now, we have established why and how to label our system, and now let's see where to label, where to place all of these labels. That is equally important and crucial. So let's discuss these guidelines, and no matter how well designed our label is, it actually gets seen and understood in the real world conditions. When we are deciding where to put the labels, we have to consider these four items over here. First, we need to be sure that it is visible. So labels should be in plain sight, and they should be located in a place where the people can interact with, and that are basically visible, and that there is nothing covering them. The place is labeled correctly, and the people can see and will interact with the label before touching any internal components. The second thing is the proximity. So we have to put the label as close as possible to the high voltage component without being hidden by other parts. So if you label it too far away, the people might not see, and it will not make the connection between the part and the label. And if you put them too close that it is hidden by other parts, it will have the same effect. So we have to take care of the proximity. Then we have the orientation. So the label should be readable and upright, so no one wants to tilt it or modify or change the location or rotate it, because at first sight it is already in a readable location. And finally, the lighting and contrast. If the label is, for instance, in a dark area, we have to consider adding artificial illumination, or to consider it to be reflective, to ensure that the background color doesn't blend with the label and that it is very visible. These are basic principles that ensure that the critical warnings don't get buried in the clutter and don't go unnoticed. Besides of that, the placement of the battery of the labels will go across the full electric vehicle. Usually we will need to place labels in the battery packs, near access panels or the removable covers, in such a way that the technicians can see the label before opening the batteries. Also in the vehicle we have to include them in all the high voltage cables. So we need to mark the cables at regular intervals, for instance, and to use the color orange to identify the high voltage cables. And the inverters and converters, the casing of the power electronics, also should have clear and big labels. The charging ports should alert the owners and any service person or any person that is doing servicing about the potential shock risk. There is an element that is very important in the vehicle, that is the service disconnects. We will go deeper about this emergency disconnect element, and it also has to be labeled, as well as the motor compartment. If you open the motor housing and you see orange or a big warning sign, that might create a reminder that you are dealing with the high voltage. And also in general, emergency guides of hood zones or under the hood should incorporate of these labels. The idea here is that the people that are interacting with the vehicle will see these warnings and can prevent them from accidentally sliding into a live cable, or during rescue operation to touch something that they shouldn't, and to avoid the hazard of electric, any electric hazard. Up to here we have covered also the labeling extensively, and there is only one topic that is left, that is the lockout and tagout, or the LOTO, and this is very connected to the labeling of the high voltage systems and the safety, because it helps to ensure that there are not accidentally that the system is not accidentally energized while we are doing maintenance, or while we are repairing the system. So we can think on this as the ultimate do not disturb sign. If we are physically disconnecting our equipment with a switch and we are locking it, we can keep everybody safe, and it is like the ultimate measurement of safe, as we will explain next. So, what is the lockout tagout, or the LOTO? Basically, as you can see in this figure, it refers to placing a physical lock and a tag into a power source. For instance, when we have a circuit breaker or a valve, in this case we can prevent the re-energization of the equipment while someone is working on it. The lock that we can see over here keeps it from turning on back, and the tags will warn others that the machine is undergoing maintenance and that must not be operated. In general, this system exists because not all the dangers are going to be visible, and a machine might look off, it might look de-energized, but there might be residual energy, and there might be, for instance, unnoticed secondary power sources that can still pose a risk in our system. So with this simple lock and with this simple layer, we are clearly and physically locking the switches, and we are in such a way protecting the individuals that are doing work and anyone else that might be, for instance, close to the power source. So this prevents unexpected startup of the system, and it prevents also potential injuries. So the high voltage electricity isn't the only dangerous energy source in our system. We can use the same protection, the same lock, to keep other types of sources or sources of risk controlled. For instance, so there is the electrical that we already talked about. When we are having de-energized circuits, we are disconnecting the power cords and we are placing them and securing them somewhere else with a lock. We can also have mechanical security parts, and we are going to be securing moving parts with blocks or steam and putting a lock into that. We can also use it for hydraulic systems and releasing pressurized fluids and then closing the valves and putting a lock into it. We can also be blocking pneumatic systems and blocking air pressure lines, for instance. In the chemical systems, we can insulate the tanks, the pipes, and any hazard chemicals, and in the thermal ones systems, we can also allow the equipment to cool down and insulate all the heat sources. So in general, we can have a system that combines several of these types of hazard energy sources, and in those cases we can lock them individually or together and protect finally the users. This lockout tagout at the end is a procedure that we have to do. These are the 6 steps that we have to follow up. The first step is then to notify the employees. So everyone know that you are about to shut down the equipment. We notify everyone that is working around that the equipment is going to be shut down, that the vehicle is going to be de-energized, and everyone, only the people that is going to be performing the procedure, stays working in the system. The second step is then to actually shut down the equipment. So we will take we will power off using the stop button or turning off the vehicle using the standard equipment. The third step is then to isolate the energy sources. So we will pull the main switch, we will close the valves, or we will remove the fuses, and we will ensure that there is no energy that will flow in our system, not even from other sources. If we have a switch, we can physically take it out. If we have a fuse, we can physically take it out. The next step is the fourth one, that is to apply the lockout and tagout devices. So in this case, we will attach a lock and a tag that is physically that makes physically impossible to turn the equipment on again. So for instance, we can take the disconnect switch and put it into a safety box in such a way that only if you open the lock you can access the disconnect switch, or you can physically put the lock in a place in our system that do not allow us to access the switches again. That is the fourth step. The fifth one is then to release the stored energy. Even after we have isolated the system, there could be some energy that is, for instance, stored in the capacitors, and that is, or in the case of electricity, it might be stored around the capacitors, or in case of pressure system, it can be stored in the springs or in other elements. The idea is to release that energy in a safety manner. And the final step is to verify the lockout. So we have to try to start the machine again, to start the vehicle again, and be sure that is not possible, and be sure that it stays with zero energy, that it is not electrified. In this process, there are common errors that we have to avoid. For instance, skipping the verification step, failing in something like this, and to say that the system is isolated and that it is not energy flowing, and when someone goes and work, like having the certain that it is safe, it might encounter a hazard that he was not expecting because we skipped the verification step. Also, if we use damaged lock device or damaged tags, it is another common mistake. Failing to communicate to the team members or removing the locks or the tags without the authorization. All of these are problems that should be considered. So this is the last part of this model. Thank you very much for your attention. In this case, we have combined all the different standardized labels, the colors, the analysis of the text, durability, and so on. And all of these are the measurements that significantly reduce the risk associated with the high voltage system. To stay safe and to remember to have these clear warnings, even to have procedures like the LOTO, can really make all the difference. So thank you, and let's see each other in the next module.